Hello, everybody. I'm Massimo Tisi. I'm a professor from IMT Atlantique, and I'm here to present the MOSAICO project that I coordinate, that is about management, orchestration, and supervision of AI agent community. So it's a project about AI agents. Just to know, in this room, how many people, can you raise your hand if you're using AI agents for your work? Or a lot of you. Half of you. Great. I do the same. To illustrate the project, I start with a simple example. This is me in the picture, and I'm giving a prompt to an AI agent. It's a very simple example just for pedagogical purposes. In this example, I'm asking the agent to generate a domain model, a set of classes, okay, and attributes, in a specific textual format that is from another Eclipse project that is called Emphatic. Then I give a short description of the domain, and of course, I want this model to be syntactically and semantically correct. Okay, now, if I ask this to any of the shelf agents, this is a very simple task, I will probably get the good solution that is the one that you see here. But you can imagine, if you try to do something like that, you can agree. As soon as the specification grows, pages of specification, you will find errors. You will find errors, syntactic errors, semantical errors, etc. So what people do, they build agents that are a bit smarter for specific tasks. And there are a lot of different approaches. Here I'm talking about one specific approach that is the multi-agent approach. In the multi-agent approach, we don't have the blue agent inferring or computing the answer by itself. But the blue agent, let's say, computes the composition of this task and then delegates to other sub-agents. For instance, in this little example, he could delegate to the green agent the task of generating the model. Then he could delegate to another, more yellowish agent, the task of syntactically validating the model. And this is nice because the yellow agent maybe is an expert in using some tools, like the emphatic parser, the emphatic validator. So it could use tools to syntactically validate the model. And then it could delegate to another agent, the teal agent, the task of semantically validating the model. And here maybe you want to use a different LLM than what the first agent was doing to have some objective validation. And things like that. So in general, this is kind of common today. People are doing this. Actually, even when you call Copilot for some task, there is some multi-agent thing going on. And of course, then the blue agent needs the way to put things together, even iterate to arrive to a model that is satisfactory for the user. Why so you do multi-agent? One, because you want to specialize, so you want to get agents that are experts in a subtask, in a specific task, so they have specific persona, tools, LLMs that are suitable for or optimal for a certain task. But then another good reason is some variability. Sometimes, especially for critical environments, you want to replicate tasks on several different agents, either because then you increase the chances of task success, or because you want to do some voting to get a single answer out of them. Sometimes people do it also for cost reason. Typically, there are some setups where an agent delegates to a cheap agent when the task is simple, and to an expensive one when the task is complicated. But of course, the method comes with a lot of problems, even if now it's becoming very fashionable. One is that there is a big overhead. So the more agents you have, the more communication, the more LLM calls, and the slower response time. And also because errors propagate sometimes unpredictably. And so you may have errors that don't cancel themselves in the network, but that actually amplify. So research is active in the area. Let's say the feeling of researchers here was very positive on multi-agent up to 2024, I would say, where there was this fashion like more agent is all you need. This is a kind of well-known and discussed paper, let's say, that was showing that even by getting a set of agents and a very simple strategy like replicating the task and majority vote for getting the best solution, you were increasing the performance of LLMs in a lot of as you can see in the picture in a lot of well-known benchmarks. But actually in 2025, there is a very nice paper by Google that shows that things are much more complex. And for instance, that if your agent is smart enough, like you see in these graphs here, at a certain point, multi-agent actually hurts your performance. You would better get the top frontier model from Google or from OpenAI, and you will get better results in tasks that you were doing in multi-agent way. But of course, also here, the research is kind of limited. The setup is very very dynamic, let's say, so the agents compute the collaboration dynamically every time. And it's up to 6 agents, so I mean, the study has its limits, but still it shows us that this is a very active area of research, and nothing is very clear. So this is what the project is about. MOSAICO is about enabling and studying the cooperation of a possibly large number of LLM-based agents. And asking ourselves, can we increase reliability in software of LLMs in software engineering by this large number of agents? It's an Horizon Europe project, 12 partners in Europe. IMT Atlantique is coordinating. We submitted the proposal in March. The project started in 2025 for 3 years. And actually, the idea comes from 2023, when we started writing this proposal. And so I'm pretty proud that we kind of predicted something that gets very, very fashionable in 2026. And you can find more information of this in the website. So we finished the first year, we started the second year of the project. So we have something to show. In this first phase, we are dealing with some components that enable at least the platform, etc. And it's in the second phase that we will deal with more the scalability part. So the first thing we have is an interface. So a user interface for MOSAICO. You can see a little screenshot in the right-hand side, and you can see that it looks a lot like Copilot. It's a VS Code extension. It's an open source extension. It's a fork of Continue. Continue is an open source project released in Apache license. And you can see here I'm using the same example that I showed you before. I give a task, I get the right answer. The only thing that you can see differently is that you can track its sub-agent. Here, it's exactly the architecture that I showed. So I have a generator agent that is completed. I have a syntactic supervisor and a semantic supervisor that each one do their job and report on their activity. Actually, the client talks with a single agent that we call the reference agent that has the role of interfacing with the user. And then the client has this purpose of exposing resources from the IDE up to MOSAICO. But this, we are still working at finalizing it. You can already download the client from OpenVS6. Okay, so you are here in the left-hand side. You send your prompt to the client. The red agent is the reference agent, but now things start getting complicated. So the reference agent, first of all, it delegates to an agent that we call the collaboration agent. The collaboration agent is an expert in decomposing tasks. And so the collaboration agent computes a plan, a workflow. Actually, in dynamic setups, it computes a workflow, but we also support collaboration agents that have hard-coded a certain workflow because we know that a certain kind of tasks are better done with a specific workflow. So you can have different kinds of collaboration agent. So the workflow computed by this agent involves a lot of other agents that are all the agents that you see here. This agent can be other collaboration agents because sometimes one of the tasks of the workflow needs to be further split to arrive to actionable tasks. So actually in MOSAICO, the composition architecture is hierarchical. But then the main agents that perform tasks are so-called solution agents that compute tasks, that performs action on the file system, that launch API calls on MCP, the blue ones. And then in most of the workflows, we want to have some evaluation that the task performed by solution agent is correct or respects some parameters and some KPIs. And so we have the yellow agents that are called supervision agents. And the task of supervision agent is exclusively to evaluate the job of a solution agent. Nice thing about supervision agent is that we can replicate them. So we can have sometimes a lot of different agents that evaluate the same work with respect to different criteria, etc. And then we need at some point to arrive to a consensus about all these evaluators. And that's the role of the last kind of agent that we have, that is this one, that is the consensus agent. The consensus agent enacts a policy for taking a decision based on the evaluation getting from the supervision agents. And this decision, they look a lot like, we have a lot in MOSAICO the metaphor of the community. They look a lot like governance rules in a community. So it's a community that needs to take a decision, and there are deciders with different roles, with different powers that can influence the decision. The solution agent especially enacts a lot of times a debate between them to arrive to a consensus. Okay, so this more or less gives an overview of the main platform at runtime. There are two global components, the orchestrator and the decision engine, that give global structures that improve especially performance. And then we have a repository that runs a background process where agents are stored. So the code of the agent is stored on a repository that we are producing in the project. And we have a benchmarking loop that allows us to run some benchmarks on some KPIs to give values that are then used to select the agents by humans or by other agents that better perform in a given task. So this is the platform. And so what does, okay, MOSAICO is an agentic platform, okay. There are a lot of other agentic platforms around there, at least in 2026. So what makes MOSAICO different than other agentic platforms? So one thing, we are heavily protocol-based. That means that we are agnostic to languages. You can write your agent in any language you want. And we are agnostic to implementation technology. You can use a lot of libraries to write your engines. What you need to do is implement a protocol, an interface, to make your engine collaborate with MOSAICO. And that means that also agents are isolated, and every agent has his own Docker container, and the platform starts and stops Docker containers on demand. So this is to make the platform open. As I said, the platform is based very much on a reputation concept. So we track the performance of the agents, either in background with benchmarks or online during the workflow execution to derive some metrics, some KPIs, and a lot of full work package of the project is given to define these KPIs and measure them. Then, and this is very important for us, the platform is very explicit. We make explicit two things at two levels. One, we make explicit the mental model. That's an old concept from multi-agent system theory. The mental model of agents as beliefs, desires, and intentions. And then the platform reasons on beliefs, desires, intentions of the agents to optimize collaboration over the network. And we also make very explicit the collaboration patterns, the collaboration workflow. That is another artifact. When I say explicit, it means that there is an artifact that represents it. And governance rules. Finally, we care about formality. So all throughout the platform, we use formal languages. Most of the industry uses Python, let's say, or JSON, let's say. But we try to use formal languages during the platform with the formal semantics. And this allows for precise communication, but also precise implementation of the platform in other technologies. So now for the rest of the presentation, I'm only talking about some components that we have that you can already look at right now and illustrate a bit this principle that I described. So the first one is the protocol. As I said, the platform is heavily protocol-based. We propose a protocol. The origin of the proposal, it was expected to be a totally new protocol. But actually, things changed. Now A2A, that is the protocol from Google, looked very nice to us, was fulfilling a lot of our requirements. So we're actually extending A2A. A2A is already as a mechanism for extension. So how are we extending A2A? On one side, we are adding a feature for observability. So we need to add the concept of hierarchical organization of agents. So here you see an observability platform. We are compatible with all OpenTelemetry systems like Langfuse, Langsmith, etc. And you can see that you can check traces hierarchically. For instance, you had the reference agent contacted the collaboration agent, but then had the three agents I talked about in my little example. So you have hierarchy, you have some metadata that you can check about the performance of this collaboration, for instance, time to first token, etc. And these are the kind of metadata that then the framework uses to take decision about optimizing the communication. And also we are adding performatives. Performatives are also an old idea from multi-agent systems. Actually, we are using a standard that's called FIPA ACL. And so we are adding to A2A also some information about how much the agent commits to some actions. So how much it commits, how much it commits to objectives, if at some point it needs to drop them from some reasons, etc. So A2A, if you know about it, is more focused on tasks. We are actually, with performances, we are adding something about the mental model of the agents that perform the task. So this is an example of what we mean about our work on protocols. As I said, the belief, desire, intention is important. So if you know what the pattern is about, so we want each agent, the agents are here, to have a precise view, because at some point they will be requested for what are their beliefs, so what they do know about the world. Typically is a set of sentences, let's say, but they could be in natural language, or we also support a formal language that is called agent speak. But imagine a set of sentences that represent what the agent believes about the world, what are the knowledge that he extracted about the world. Desires, that is the objectives that he has, and the sub-objectives that it also has to arrive to this global objective. And intentions. Intentions is what is the commitment to some actions that he wants to perform right now, as soon as possible. Okay. So MOSAICO has a library that gives you, so you could implement your own agent and just implement the protocol and be able to answer to our request for beliefs, desire, intention. This is up to you. Or otherwise, you use our library in the implementation of your agent, and our library gives you some nice utilities for BDI management. And again, so we use BDI to orchestrate and moderate the communication among agents. For instance, we can use it to find compromises when you see that two agents disagree. We can use it to share knowledge. So one agent learns something that could be useful to the other, some new belief. We can share it automatically with the others. We can block two agents that they want to do some conflicting actions because they have some intention that conflict with each other. And finally, I have an example, I think I'm on time. I have an example about formality. So when we represent all these things, we try to use formal language. For instance, to represent the collaboration among MOSAICO agents, we are relying on a language that comes from a very different domain, that is SysML, that comes from system engineering. But we really like it, so we defined a subset of SysML that applies to agent collaborations. And the subset, we like it because it has SysML as a native textual notation that is here. It has an imperative style. I will show the workflow right after. It has a formal semantics that we really care about. It's already known to frontier LLMs, and there is a lot of tooling. For instance, Eclipse has the Season project that has an editor for it. So we selected, we also published a big data set, 75,000 SysML models, workflow models like the one I'm going to show. that we are using to fine-tuning an LLM for being a better planner, so a better collaboration agent in our framework. So in the picture you see the part where we define that there are 3 types of agent, and we see we can add some constraints. For instance, here the only constraint I added is that these agents need to include some skills that are emphatic generation and the syntax validation and semantic validation for the 3 agents of my example. And these skills are automatically used to search in the repository for agents that satisfy these constraints. But these constraints can also include a lot of KPIs like performance in these skills, etc. And then you define some instances of these types of agents. For instance, in this case, I'm getting for the first one, in our demonstrator, we have a Python implementation that uses small agents, and they use some tool for producing emphatic code by Jinja in the Qwen3 LLM. We have a syntactic validator that does not use any LLM at all, actually, just uses the emphatic parser and gets nice errors if it finds that that model has some syntactic errors. And we have a semantic validator that uses LangChain and is written in Java. So as you see, different technologies and different frameworks. Then once I defined these models, I have these agents, I can specify a workflow. So here you find a little workflow that I drew for this example. This is generated by Plan2ML actually automatically, but this is the native textual format where I just have, as you can see, a very imperative notation in the sense that it starts from here and then I perform this action and then I perform this other action. So even if I'm drawing a graph, it looks more like a procedure, and the LLM, there is a nice paper also recently that showed that LLMs are kind of bad at producing graphs, but they are much better at producing imperative code. So that's more or less what this looks like. Okay, so this is what I wanted to show. The MOSAICO consortium, we are 14, we have four universities with different competencies. We have Netcompany that does integration. We have Codo that is a big actor in VS Code LLM-based tools that deals with fine-tuning and prompt engineering. We have Eclipse as a partner, F6S for communication, and we have 4 use cases. And for use cases, just a couple of words. We try to apply this to very different kinds of developments. So with Immersion, we develop energy-efficient mixed reality content. With Collins Aerospace, we try a very challenging thing that is applying to some development that requires some certification too. In this case, the prediction component for the remaining useful life of an aerospace plane. With one parallel, we deal with the catalog of IoT solutions, and the National Bank of Greece, we do some investor recommendation system with some data science. In all of these, we evaluate how the set of agents helps normal developers in developing these systems. Finally, MOSAICO is open in all senses, I would say. We have MIT license for all the code, and all the code is on the Eclipse GitLab. All the data sets and experimental data is on Zenodo, so you will find all data we have. All our applications are on open access. Our technical reports from the projects are public. Eclipse is a partner. And also we are open to contributors and collaboration, so the consortium is not closed. Finally, and I close with this, we have a demonstrator that is the probably easiest way to get the platform and have it running and try it out. So you can go to this tiny URL, but if you go also on the Eclipse GitLab, you will find it. So the demonstrator, you can also try it at the booth in the main room. I think more or less at the center of the room, right in front of the coffee. And in the demonstrator, we'll find the client. You will find a little set of agents, and you will find all the agents that I discussed in my little example. You will find the repository with the vector DB, And you will find some observability with Langfuse, so an installation of Langfuse with the storage it needs. That is all. Thank you.
So, I don't know if you have any question. Yes, we have a question there.
Michael Beerisch, German Aerospace Center. Thank you very much for the talk. I have a question concerning your initial remarks about what may be the drawbacks on having multiple agents. So do you already have some, let's say, data points now? So when you cross the threshold, let's put it this way, when does it apply, this mechanism? When is it better to use just a single agent?
So we don't have anything that I would feel confident in sharing, okay? But the point is that we find the best, let's say, advantages we find is when it's for hard-coded workflows. So when you have a clear workflow, you hard-code the workflow, you have your sub-agents, etc., it's easy to get gains. But in terms of dynamic workflows, so far, our results are kind of unstable, I would say. So I think next year we will have better answer on that too.
Yes, we have another question.
First of all, it's a very interesting project. It's very exciting to see those things. What would be the open source, let's say, building block that you want to propose here? Is it an overall system or? Yeah,
so it's a system. This is it. I had some backup slides. So, yeah, it's a system. Actually, there are 4 main components. One is the protocol. One is the repository. One is the orchestrator with the collaboration agent. So the orchestrator and the collaboration agent go together, since the collaboration agent devises the orchestrator and the orchestrator enacts it. And one is the consensus agent and the decision engine that go together in another different component. So this is what we are delivering here.
So there's a very important thing. You have an implicit architecture with a taxonomy of agents. The supervision agent is so important because it's validating the solution agent, because otherwise you don't trust the solution agent. Okay, so this is why I like the architecture. And my question is, will you promote this at standardization level, knowing that there's no reference architecture on AI agents right now? So there is an opportunity. It's hard, but I can help.
That's a very good point. So we didn't dare to talk about standardization in the proposal, but yeah, I understand that is a very good point. So the point is that it looks to us that in industry, a lot of agentic platforms are out there. In a lot of times, they give you some tools and they say, okay, now you deal with it, you build your agent and they will just work, or at least it's up to you to make them work. So we want to try to do something much more managed than what you see in the company. So supervision agents are one step, collaboration and consensus agents are the other, where everything should work because there is some intelligence in make it work together.
We discuss further.
Okay, so we have more work to do. That's good. And I have some questions. A couple of them, but I think I need to choose some of them. You always are free to don't answer. I remember from my study, believe, desire, intention, and that's the agent that you are building. About the beliefs, do you have standard beliefs that you inject to them? Because if I remember, beliefs is where you have problem in agents.
Yeah, I mean, actually the development of our agents passes through there. So when you develop an agent, you need to put an agent in MOSAICO. you typically put things in these terms from the beginning. So you see what are the initial beliefs that are more or less the persona that you write down, and what is the objective, and what should be even some little plans. So when the belief is this, you want to do this, etc. So we really use it to design our agent because it's convenient to do so. As I said, it's not mandatory. You can write your agent as you prefer, but we do that. And in this case, yes, we do a lot. We have a lot of initial beliefs that are the system prompt.
Can we say supervised? Beliefs are supervised?
Yeah, this we can say it. So the beliefs are visible. So this mental model is inspectable. So we inspect it for two reasons. One, the framework inspects it, and two, you can also inspect it yourself for explainability of a decision. So you can look at why you got some decision and what are the beliefs that are there. But yeah, it's inspected also automatically by the framework, and the idea is really to supervise that there is not a wrong belief that then gets propagated and convinces all the other people that
yes, that was I was remembering from my study. Yes, so that's.
There will be a language to describe the belief.
Yeah, so we have two. For now, we have a formal language that is called AgentSpeak. Also comes from the old times. We actually just integrated it somehow with LLMs. So we will find, for instance, a translator from AgentSpeak to natural language. But we also support beliefs in natural language. And in this case, for do every reasoning on those, you use LLMs.
That's excellent that we are talking about natural languages, but we have another question.
Thank you. My question is a little bit related to the governance, and once again, this specificity. In the governance case, when you have the what you call collaboration agent giving the orders or the actions to the solution agent, it can give the action to different ones at the same time. So in that case, the governance, how is it linked, and how is that the receiving one is going to get the exact objective they want to without changing their beliefs per solution agent? So
in our terminology, let's say, we have two kinds of workflows. One workflow is the one devised by him, and yeah, in the collaboration agent sends maybe the same task to n agents, okay? And this is very procedural kind of workflow. And then here, the consensus agent instead is the one responsible of the governance. So at some point, some decision needs to be taken. For instance, the decision is, should this file be put on the file system of the user, let's say. And so to get this decision, he uses a set of rules that are the governance rules. And so, for instance, he needs a validation from these agents, etc. Or it needs that the majority of them thinks that this is a good file. And these rules actually, as I said, can also invoke a debate. So actually, it can also trigger again these evaluators and even trigger again some solution agents to produce new solutions if none of the solutions are correct. I'm not sure if I answered exactly your question.
Yes. I have more questions now, but yes, you did. Thank you. Just one thing: who defines the governance rules? Like, is it already from the beginning, or they adapt?
Yeah. So the governance rules so far are all coded, so we write them manually. Okay. For instead the collaboration part, we have two options: either we write it manually, or it's automatically derived by the LLM. Just that. The project is limited and we don't have time to study how to derive these governance rules automatically. Yeah.
And I was about to say that that's outside the project, but just a discussion between me and you, because one main point that is discussed in some small research is about the language. Not the programming language, but the language. Like the English that is using in the agent, because the English is not really a great language for describing things, so it can be mistaken, it can be ambiguous. So do you think, that's outside, do you think that we need at a certain point to have dedicated agents for dedicated languages?
That's an interesting question. It depends. I think that there are some agents that are really, that could be tied to languages. There is no reason why they should be. The language problem should be a problem of the LLM. So there are LLMs that are very good in some languages, the LLMs that are just focused on English, etc. So the problem should stick with the LLM. But actually a lot of times people are programming agents putting English prompts, and so there are some issues related to the language in the agent development, right? Well, honestly, this is, it's a MOSAICO problem in the sense that we try our agent to be language independent. Let's say our agents are actually just the collaboration agent and the consensus agent. But up to each solution agent and each supervision agent, it's up to the user to write them in the right way, let's say.
Yes, of course. Okay, yeah, that is an interesting. Yeah.
Yes,
MOSAICO
MOSAICO
languages. Yeah, that is an interesting, very small get to research, but it's a very interesting one. I will say that it's time to wrap up for this morning. We have lunch. As I mentioned to you, we have mandatory breaks. So we have lunch at 1, so 5 minutes for now. And we are coming back here at 2. Okay, so we will see each other in 1 hour. Lunch will be served in the exposition area, and it will be catering buffet. Okay, so it's also a way to know each other or, know other person. Okay, so enjoy the lunch and see you later.